Early in the 20th century, around the 1920s, researchers developed
Check 1. Check 1. Check 1. Check 1, 2, 3. Is it loud and clear? Good evening everybody, can you hear me? Good evening everybody, can you hear me? If you can do the chat right. Okay, great. Right, good evening everybody. Welcome to another edition of Final Countdown. This is week number 4, day number 1. Let's get into work as quickly as possible. Right. Have a look. First question. The unit of intensity level of sound. Sound intensity watt per meter square. Sound intensity watt per meter square. Sound intensity level will be decibel. So here you go, dB. Decibel. So sound intensity that is watt per meter square. That is watt per meter square. Sound intensity level that is going to be decibel. That's going to be decibel. So our correct answer is answer number 5. I'm sure all of you have got that. So the clarity is between these two. Remember, sound intensity is watt per meter square. Sound intensity level is decibel. Level means decibel. Okay, no? Right. Okay. Moving on. Which of the following quantities must be known in order to calculate the energy consumed by electrical appliance? Energy consumed by electrical appliance means kilowatt hour. Right. So technically you should know the power. And of course the time. Yeah, power and time. So look at this carefully. So power consumed and time of operation. So power is here, time is there. So directly we can say answer number 4. Directly we can say answer number 4. So remember the 2003 paper, slightly tricky, but very good questions were asked. So power consumed and time of operation. So consumed power is kilowatt hour. Consumed power kilowatt hour. Kilowatt is power. Time is hour. So power and hour, power and time very important. Right. Moving on. Moving on. Of the elements given below, power VI can be amplified. Amplification. Right. Look at this carefully. Resistors don't increase the power. Input power and output power are almost same. Diodes, there is no amplification. Diodes, they can rectify, no amplification. Capacitors also no voltage amplification. Transformers also input power, output power is same, ideal transformers. Only transistors can amplify. Remember, transistors can amplify current, they can amplify voltage, and they can amplify what? Power. All these three things can be amplified in a transistor. Right there. A transistor can amplify. A transistor can amplify. Transistor can amplify voltage, current, and power. Voltage, current, and power. Okay? Voltage, current, and power. Right. Moving on. A cricket ball is hit for a 6. Leaves the bat in the upward angle of 45 to the horizontal. So here, angle 45 to the horizontal, right? With the kinetic energy of K. So the mass is m, velocity is u, right? Kinetic energy of the ball at the top of the flight. So at the highest point, vertical velocity is 0. Only horizontal velocity is there, u cos 45. There you go. So kinetic energy K is equal to half m u square, equation number 1. At the highest point, kinetic energy K dash, half m u cos 45 whole thing square. Half m u cos 45 1 over root 2 whole thing square. Half m u square half. What is half m u square? Half m u square is k divided by 2. K divided by 2. So k divided by 2 is there, answer number 3. K divided by 2 is there, answer number 3. Okay, no? That's a pretty simple one, but anyway important. Every MCQ is important. Yeah. Every MCQ is 1 mark. Every MCQ will increase your Z score. So every MCQ is important. Right. Look at this one. A golf ball of mass 0.05 leaves with a velocity 70 after being struck by a golf club. So golf ball is initially at rest. Contact with the golf ball is given as the mean force. Force into time is equal to mv minus mu. Okay, no? So force into time 5 10 to the power minus 4. 0.05, final velocity is 70. Initially golf ball is at rest. Initially golf ball is at rest. Simplify this. 5 10 to the power minus 4. Simplify this. 352 decimal places 3.5. F is equal to 0.7 10 to the power 4. Jump a decimal. 7 10 to the power 3 newtons. 7 10 to the power 3 newtons. Here you go, answer number 3. 7 10 to the power 3 newtons, answer number 3. 7 10 to the power 3 newtons, answer number 3. Right. Okay. Moving on. Moving on. The graph represents the velocity with time, Vt graph, constant negative gradient. Corresponding displacement time graph, be careful. Now here there is a positive area, here there is a negative area. So your displacement time graph is a deceleration with an acceleration downwards. Here deceleration coming to rest, turning back and going in the opposite direction. Correct answer is answer number 2. Correct answer is answer number 2. This is a positive displacement, this is a negative displacement. Going forward, going backwards. Okay? Going forward, going backwards. Right. Moving forward. Now these from your thermal physics. Adiabatic process. Tell me, what's adiabatic process? Adiabatic process is a process where there is no heat transfer. Delta Q is going to be how much? 0. Now all of you all know delta Q is equal to delta U plus delta W. Delta Q is equal to 0 means delta U plus delta W. Delta U is equal to minus delta W, right? Minus delta W, right? No heat enters or leaves the system. Correct. No work is done. That's wrong. Temperature system remains constant. That is in isothermal. Pressure of the system remains constant. No, wrong. Volume of the system remains constant. Wrong. Only correct answer is answer number 1. Answer number 1. 7. Answer number 1. Okay. Right. Moving on. Look at this. Which of the curves shown below represents the output characteristic graph? I think in the 2000 papers this was there. The output graph is drawn between IC and BCE. IC and BCE. Correct answer directly is going to be answer number 4. Correct graph directly is going to be answer number 4. This is your output characteristic graph. Remember, I'm additional putting here. IC is in milliampere, BC is in volt. IC is in milliampere, BC is in volt. Correct answer, answer number 4. 8, answer number 4. What do you call this characteristic? Output characteristic. Output characteristic. Right. Next one. If the mass of a radioactive sample is double, now remember, mass of a radioactive sample is double means number of nuclei will double. Which of the following is correct regarding the activity? Activity is equal to A naught. No need to write the what you call actual equation. No need to write the actual equation. But we can say like this. No? Activity is proportional to number of radioactive nuclei. From this we can say A is equal to minus lambda n. Why is the minus sign? With time, number of radioactive nuclei will reduce. So I will just take the magnitude. Magnitude is lambda n. Right. What about the half-life? Half-life is equal to 0.7 divided by lambda. 0.7 divided by lambda. For a material, for a single material, the half-life will not change. Half-life is constant, property of the material. Even if you double the mass or triple the mass or quadruple the mass, half-life is always not same, right? So if you double the mass, number of nuclei increase, activity increases, half-life remains the same. Correct answer, answer number 3. Correct answer, answer number 3. Right there. When we double the mass, the number of nuclei will increase. Number of nuclei will increase. Number of nuclei will increase. When number of nuclei increases, activity will increase. Number of nuclei increases, activity will increase. Number of nuclei increases, activity will increase. But the half-life is a property of the substance. But the half-life is the property of a substance. Half-life is the property of the substance. And the half-life will remain unchanged. And the half-life will remain unchanged. Half-life will remain unchanged. Okay. Right. Moving on. Next one. Photoelectric effect. We have done this many times. 2000, 2001, 2002. Every year this was there. So there is a metal plate. It's illuminated by photons HF. Electrons will take some work to come to the surface. Excess electrons will emit with maximum velocity, right? A metal plate is illuminated with a beam of light of a certain frequency, right? We also know incident frequency should be greater than threshold frequency. If incident frequency is greater than threshold only, photoelectrons are emitted. Photoelectrons are emitted. Photoelectrons are emitted. Photoelectrons are emitted. Okay, no? Right. Which of the following determines whether electrons are emitted or not? Emitted or not? Intensity of the light, wrong. This is your condition. Length and time exposure, no. Surface area, type of metal, speed of the incident photons, this is correct. Reason: from metal to metal, work function or the threshold frequency will change. From metal to metal, F naught will change. F naught will change. Okay, no? F naught will change. So your correct answer there, 10th answer number 4. 10th one, answer number 4. Right. 10th one, answer number 4. Question number 11. Question number 11. Consider the following statements made regarding the speed of sound in air. What's your equation? Speed of sound in air. V equal gamma RT over molar mass square. Speed increases with increased pressure when temperature is kept constant. Wrong. Temperature constant. Look at this. P is equal to rho RT over molar mass. Pressure proportional to density. Remember, there is another equation, gamma P over rho. When pressure increases, density increases. Pressure increases, velocity will increase. Density increases, velocity will reduce, cancel off. So here, when pressure increases, technically there is no change in V, no change in velocity. Statement A wrong, whatever with A is also wrong. Whatever with A is also wrong. Method of elimination. Quickly, whatever with A is wrong, method of elimination. Right. Speed increases with increase of temperature and humidity. Correct. When speed increases, so only correct answer is answer 2. Temperature here, V proportional to square root T. T increases, V increases. Next is V inversely proportional to square root rho. Humidity increases means air density will reduce. So velocity will what? Increase. High humidity. Humidity is high means density of water vapor is more, density of air is less. Density of air is less. Lesser density of air means greater velocity. So only one possibility is there. Correct answer is answer number 2. 11, answer number 2. 11, answer number 2. That is one sentence there. When pressure changes, velocity of sound in air will not change. When pressure changes, velocity of sound in air will not change. Velocity of sound in air will not change. Right. Okay. Moving on. Consider the following statements made regarding longitudinal and transverse waves. Only transverse waves can undergo diffraction. Wrong. Reflection, refraction, diffraction, interference. Polarization is also a property. Longitudinal waves don't undergo only polarization. Everything else they undergo. So statement A is wrong. Whatever with A is also wrong. Whatever with A is also wrong. Whatever with A is also wrong. Next one. Both type of waves undergo interference and diffraction. Correct. Both types of waves can produce beats. Correct. Beats is interference. So B and C correct. Answer number 4. B and C correct. Answer number 4. Okay. B and C correct. Answer number 4. Right. Question number 30. A broad beam of parallel light is to be converted to a narrow beam of parallel light. So broad beam of parallel light convert into narrow beam of parallel light. Well, two convex lenses are perfectly okay. Two concave lenses we can't use because it diverges. Convex and concave was a card, it diverges. So only correct statement is answer A. Only correct statement is, sorry, give me a second. Here, let's not much it. Two concave lenses can't. We look at this situation, a convex lens and a concave lens. Convex lens and a concave lens. Right. Okay. How will this work? This was possible because I remember doing essay. Let's see like this. Parallel rays seem like to meet here, which is the focal of the second lens. Focal of the second lens. So light rays will become parallel. These are also possible. A and C possible. A and C possible. Answer number 4. See where they are on this. So virtual object image from the first lens, object for the second lens is virtual. And this is formed at the focal. If it's formed at the focal, broad, it will become parallel ray. Okay. So A and C possible. Right there. Right there. When there is a concave lens, when there is a concave lens, we make sure that the image from the first lens is formed at the focal of the concave lens. The image from the convex lens is formed at the focal of the concave lens. This would give us a narrow parallel beam. Right. Moving on. Okay. Identical lamina cut to form a letter E, pivoted vertically at x, G is the center of gravity. Stable equilibrium, what's the condition? Center of gravity must be below pivot point. This will give you stable equilibrium. What is unstable equilibrium? Center of gravity above pivot point. Unstable equilibrium. Center of gravity coincides with pivot point. What do you call it? Neutral equilibrium. So they want stable equilibrium. Center of gravity below pivot point. A and C possible. A and C possible means 14.1, answer number 1. 14.1, answer number 1. These are your conditions. Carefully write it for the ones who need it. These are your conditions. Right. Which of the following statement is correct with regard to angle of deviation of a monochromatic ray of light? Monochromatic ray of light. Delta is equal to I1 plus I2 minus R1 plus R. So R1 plus R2, you can say delta is I1 plus I2 minus A. Okay. First one. D is independent of the incident angle. Wrong. Depends on the incident angle. Right? D always increases with the angle of incidence. Wrong. If I plot the graph, I1 delta reduces, increases. It has a minimum point. It has a minimum point. D always decreases. Wrong. D has a minimum value and is independent of the angle of the prism. Wrong. Depends on the angle of the prism. So correct answer is answer number 5. D has a minimum value which depends on the prism angle. Okay, now these are pretty direct. Guaranteed you can score marks. Huh? Guaranteed you can score marks. Right. Okay. Which of the following images cannot be formed by a concave mirror? Now concave mirrors are there from your O-level knowledge. Concave mirrors are there from your O-level knowledge, so you can't say no there. Now, generally, will they repeat this particular question again? Normally the answer is no. These kind of things they might not repeat. But you can't say that they can't use it as well. Right. Which of the following images cannot be formed by concave mirror of focal length f? A real inverted image larger than the object. Okay. Can form. So here you go. Right. So focal is here, center is here. Center is technically 2F. Here optical center is there, right? So if I draw the rays, real inverted image larger than the object. Virtual erected image larger than the object. Inverted image larger than the object. Formed at a distance more than 2F. Formed at a distance more than 2F. Inverted image having same size as the object. At 2F is formed. These are the form. These are the form. Inverted image smaller than the object and formed at a distance more than 2F. Look at this carefully. If you take a mirror, inverted image larger than the object is formed at distance more than 2F. If this is correct, this can't form. Inverted image larger than the object formed at a distance 2F. If this occurs, this can't take place. So false statement is answer number 5. False statement is answer number 5. Okay? Right. Right. A circular hole is made from a steel sheet. circular hole is made. Now you all know the theory. When expansion occurs, the circular hole also will expand. Similarly. When the temperature of the circular hole is made from steel of linear expansivity, when the temperature is raised by 100, the area of the hole. So final area equals initial area 1 plus 2 alpha beta delta theta. So A2 equals A1 plus A1 2 alpha 100. Simplify this. A2 minus A1 divided by A1 is 200 alpha. 200 alpha is equal to 1.2 10 to the power minus 5. So 2.4 10 to the power minus 3. Fractional increase is 2.4 10 to the power minus 3. Correct answer 17, answer number 1. Correct answer 17, answer number 1. So these are very direct, but if you want it, write it down. Fractional increase in area. A2 minus A1 divided by A1. Right? That is one sentence. When we increase the temperature, the diameter of the hole will also increase. The diameter of the hole will also increase. Diameter of the hole will also increase. Just like a linear expansion. Just like a linear expansion for the diameter. Just like a linear expansion for the diameter. Therefore, the area will also increase. Therefore, the area will also increase. Okay. Area will also increase. Right. 3 identical straight metal wires are subjected to following changes separately. 3 identical means dimensions are same. 3 identical means dimensions are same. Are they from the same metal? Maybe different metals. Length is increased by stretching. You can increase the length by stretching, yes. If you apply a force in that direction, length can be increased. Length can be increased. The temperature is increased. Be careful. The temperature is increased. Three identical straight wires are subjected to the following changes. Which of the above will cause an increase in the resistance? So when you increase the length, rho L over A, L increases, R increases, right? Temperature increases, correct? R theta is equal to R naught, 1 plus alpha theta. Temperature increases, resistance increases. The wire is coiled into a solenoid. Like you coil into a solenoid, will the length change? No. Will the area of the wire change? No. Will the resistance of the wire change? No. So this will not affect. A and B only. A and B only, answer number 4. Right there. By coiling it to a solenoid, the length, cross-sectional area will not change. The length, cross-sectional area will not change. Therefore, the resistance will not change. Therefore, the resistance will not change. Right. An electric water heater has to supply hot water at 40 degrees Celsius at a constant rate of 1 kilogram per second from water at 30. So water at 30 degrees, electric heater has supply hot water. We have to supply hot water outlet at 40 degrees Celsius. If the heat loss surrounding is detected, the minimum power of the heating element that should be given. So what? Heat given equal heat absorbed. Heat absorbed. Okay. Heat absorbed. Right. Heat given divided by time, heat absorbed divided by time. This is the power. Mass of water, specific heat capacity of water, change in temperature of water over time. Mass of water here 0.1, 4200. Change in temperature 40 minus 30, 10. So here 4200 watt. Answer number 2. 19 answer number 2. Wait. 4200. Sorry, it's not 0.1. No? By mistake, it's not 0.1. It's 1. Then 4000 or 42,000. 42,000. That is 1.2 10 to the power 4. 1.2 10 to the power 4. 1.2 10 to the power 4, answer number 1. 1.2 10 to the power 4, answer number 1. Okay. Right. Question number 4. I am doing it at the same, almost the same speed as normally how you would do the MCQ. Right. Two containers A and B, volumes V and 2V respectively are connected by a narrow tube. Initially the tap is closed. A and B each contains n moles of ideal gas at the same temperature. So n moles of ideal gas at the same temperature. Tap is closed. Right. What are they asking? When the tap is open, when steady state is reached, number of moles of gas remaining in A is, what is the amount of gas remaining in? Right. Okay. So once you open, tell me what will happen. Gases will travel from high pressure to low pressure until the new pressures are same. New pressures are same. Here there will be a different pressure. Here there will be a different pressure. But what can you say about the total number of moles? So here if you look at it, same temperature, no? Are they maintaining same temperature? Yeah, same temperature. Same temperature is maintained. Now look at the equation PV equal nRT and tell me T same, R same, volume is same, different. Number of moles same. Where? Pressure is inversely proportional to volume. Larger volume, lesser pressure. So P2 is less than P1. High pressure to low pressure, number of moles will travel. So here n minus x. Here it is going to be n plus x. N plus x. Right. Look at this carefully. Total number of moles n plus n. Total number of moles finally. This is n1. This is n2. n1 plus n2. They are asking how many moles are moving out. How many moles are moving out? Look at the board carefully. Now there are many ways to approach this. One in terms of pressure. Okay. One in terms of pressure. Number of moles of gas same means fixed mass of gas. The mass here and the mass there same. Same gas was there telling. Okay. Now when I open this, high pressure, low pressure gas will travel. High pressure, low pressure gas will travel until the pressures are equalized. Until the pressures are equalized. Right. So they are asking you how much moles of gas are leaving from it. How much moles of gas are leaving from it. So final pressures are equal. Final pressures are equal. Let's approach it like this. Look at the board. If you conventionally approach like this, number of moles is PV over RT. PV over RT. Look at the board. Here pressure is P1, volume is V, RT. Here pressure is P2, volume is V, RT. Here pressure is P, volume is V, RT. Here pressure is P, volume is V, RT. You won't get any progress. RT, 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 RT cancel off. Here volume is 2V, don't forget. Here volume is 2V. All the V values cancel off. From this you will get P1 plus 2P2 equals 3P. P1 plus 2P2 equals P3. Look at the board. Look at the board. What is pressure P1? nRT over volume. What is pressure P2? nRT over volume. What is pressure P? Pressure P n minus x RT over volume. Now from this you can simplify. RTV in there. RTV simplify. Here 2n equals 3 times n minus x. 2n over 3 equals n minus x. X is n minus 2n over 3. X equal n over 3. X equal n over 3. Right. What are they asking you in the question? What is the number of gas moles remaining in A? So n over 3 left. Remaining is how much? Remaining is n minus x. That is 2n over 3. 2n over 3, there you go, answer number 3. 2n over 3, answer number 3. So mole correction is there. From the mole correction, go to the pressure relationship. From the pressure relationship, you can get the required answers. From the pressure relationship, you can get the required answers. 2n over 3. 2n over 3. Right. So total number of moles in the system before and after same. But number of moles same, so fixed mass of gas, volume is different. So fixed mass of gas means we can say temperature same means here and here Boyle's law I can apply. Pressure will double there. When I open this, high pressure, low pressure gas will travel. From here, X moles go out, X moles added here. Total number of moles same. In terms of pressure, I write get the relationship. For pressure, I substitute in terms of nRT and volume. Here, P is going to be this pressure P, n minus x RT over V. Simplify. I can get X. N minus x already here, 2n over 3. Actually, no need the rest. But from here you can find the remote. N minus x is going to be 2n over 3. Okay, no? Right. Okay. Now out of 20, check and see how many MCQs you got. Okay. Important. Right. Moving on. In an experiment to find the density of coconut oil, you are provided with the following U-tube mounted to a vertical frame with appropriate scale, sufficient amount of coconut oil and funnels. Draw a labeled setup. So remember, when you draw it, make sure you represent it correctly. There you go. YouTube is there. Make sure the scale is connected properly. Make sure the scale is connected properly. Here, zero. Linear scale. Right. What else? Water, sufficient oil, funnel. Remember, you must use a funnel here. Important. Using the funnel only, oil will drain along the inner surface. Oil will drain along the inner surface. Oil will drain. Taller oil layer. Taller oil layer. From this, don't forget to mark common interface. High density water will have a short water layer. This is water. This part is oil, coconut oil. How do you measure the heights? Remember, this is common interface. Common interface. This is your linear scale. Linear scale. And don't forget, we'll measure the height of oil above the common interface. Height of water above the common interface. Right. So everything is properly labeled. Everything is properly labeled, right now. Right. The funnel. Right. Draw the meniscus source input. Next, on the diagram drawn, mark as H1 and H2 to the measurements. Oh. I have to mark here H1, H2. H1, H2. H1, H1, H2. If the densities of oil and water are given D1, D2, write an expression for D1 in terms of D2, H1, H2. So pressures at the common interface are equal. Pressures at the common interface here are equal, A and B. So here we can say pressure at A equals pressure at B, PATM plus H1 D1 G equals PATM plus H2 D2 G. PATM cancel off, G cancel off. H1 D1 equals H2 D2. H2D2. What do they want? They want to find D1 in terms of D2, right? D1 equals H2D2 over H1. H2D2 over H1, correct? No? I'm sure all of you have got this also. Select the correct procedure out of the following. In order to draw a graph, determine adding more water. Is this good method? If I add more water, what happens? Only the common interface will change. If you want, you can write there. Only the common interface will change. Common interface will change. Height of oil and water will not change. Height of oil and water will not change. Right, that was very important on the side for your knowledge. These for your knowledge. These for your knowledge. Then what should you do? Add more oil. When you add more oil, height of oil and height of water both will change. Add more oil. Add more coconut oil. Height of oil and water will change above the common interface. Above the common interface. Okay now? So clear now? So whatever you are done, logic, directly you apply, get the answer. Right. Next one. Give the correct reason for not selecting the other procedure. Right. So why we wrote that here. We wrote that here. If we insert water, what happens? Only the common interface will change. Height of oil will not change. You can write that. This one you can write it down there. Okay. Right. Next one. In such a graph, the gradient was found to be 0.87. So what is your independent variable? Height of oil. H1 D1 equals H2 D2. So H2 is equal to D1 over D2 times H1. Height of oil is your x-axis. Height of water is your y-axis. Gradient of the graph. Gradient of the graph is 0.87. That is D1 divided by D2. Remember, D2 is water. Water is 1000. From this you can find D1 how much? 870 kilograms per meter cube. 870 kilograms per meter cube. Okay. 870 kilograms per meter cube. Right. Okay now? Once you need it. Right. In this experiment, which liquid should be poured to the U-tube first? Give answers. Water. What's the reason? If we poured oil first, both arms will have oil. Both arms will have oil. Okay. If both arms have oil, it's difficult to do the experiment. Okay. Next one. If you want to determine the density of coconut oil with a fractional error 0.1, what should be the minimum height possessed by the liquid column? Assume that the height of the liquid column is measured with accuracy 1 millimeter. Right. So they are giving you some important keywords. What are the keywords? Fractional error is 0.1. So delta D over D is 2 times delta H over H. This is 0.1. 2 times delta H over H. Height measured to accuracy means least count there, 1 millimeter. H. H equals, very simple, 20 millimeters. 20 millimeters. Okay, no? 20 millimeters. So the height measured, now they have given you this equation, so don't worry. From there you can find the actual height, which is 20 millimeters. Okay. Right. What is the experimental disadvantage of using mercury instead of water? Well, the first disadvantage is H1 D1 equals H2 D2. High density, smaller height of mercury column. Smaller height of mercury column. Smaller height of mercury. Therefore, large fractional error. Large fractional error. What's the second reason? Now, let's say you insert mercury. To insert some height of mercury. To balance a certain height of mercury, the height of oil required is large. To balance a small height of mercury, the height of oil is large. U-tube will overflow. That means to balance this height, look at the word. That means to balance this height. That means to balance a certain height. Here. To balance a certain height, you put a mercury here. But to balance this small mercury height, the amount of water required is going to be very large. It will overflow. U-tube is a very small device. It will overflow. To balance a small height of mercury, the height of oil is large. U-tube will overflow with oil. Okay. Part F. Right. So important one: smaller the height, greater the fractional error. Right. Space shuttle stands on a launching pad. Let's mark the forces and go. Weight is given 2 10 to the power 6 kilograms or 2 10 to the power 7. Upward thrust needed, thrust is given 3 10 to the power 7. Force of upward thrust is given by the product. Thrust is equal to simple M or capital M into U. This is rate of burning fuel. Rate of burning fuel. This is velocity of gas relative to shuttle or with respect to rocket. Right. So these key terms are given. Right. Show that the product Mu has dimensions of force. Mu. M is mass divided by time. Mt minus 1. Velocity is Lt minus 1. That is going to be MLT minus 2. This is dimensions of force. Simple, no? Dimensions of force. So these are difficult. They have given you this part. Whatever they have given, separately write. Okay. Next one. What is the initial acceleration of the shuttle just before it leaves? Apply F equal ma in the upward direction. 3 10 to the power 7 minus 2 10 to the power 7 equals 2 10 to the power 6 into acceleration. Here 10 to the power 7, 2 10 to the power 6 into acceleration. 10 divided by 2, acceleration is 5 ms minus 2. 5 ms minus 2, right. Assume that the acceleration is constant. Determine the velocity of the shuttle 30 seconds after takeoff. V equal U plus AT vertically upwards. Starting from rest, acceleration 530. What is it? 150 meters per second. So velocity of shuttle with respect to Earth, from Earth only or do the calculation. Right. Then what? Calculate the exhaust velocity of the gas relative to the shuttle. They have given you thrust is equal to m times u. Thrust is 3 10 to the power 7. What is m? Go back to the question. Go back to the question. M is 3 10 to the power 3 kilograms per second. 3 10 to the power 3 kilograms per second. So here you can go back. 3 10 to the power 3 kilograms per second u. U is 10 to the power 4 meters per second. What is this? Velocity of gas with respect to shuttle. Okay, no? Velocity of gas with respect to shuttle. Okay. Why? They are given you this. Velocity of gas with respect to shuttle. Alright. Once you need it. Write down. Okay. Right. What is the exhaust velocity of the gas relative to Earth? After 30 seconds. Gas with respect to Earth is gas with respect to shuttle. Shuttle with respect to Earth. Gas is coming down 10 to the power 4. Shuttle is going up 150. 10,000 downwards. Bring the source downward minus 9,850 meter per second in the downward direction. That is velocity of gas with respect to Earth. So remember, your basic mechanics is completely questioned in this one. 9,850, don't forget to put the directions. And writing this equation is very important. Starting with gas, finishing with Earth, intermediate both are same. Intermediate both are same. Right. Okay. A student states that the shuttle cannot accelerate if there is no atmosphere outside. Is the statement correct? No. How is the acceleration taking place? When the rocket is burning fuel, fuel is burnt and pushed outwards. When fuel is burnt and pushed outwards, action reaction goes outwards. Yeah. So student states that shuttle cannot accelerate if there is no atmosphere outside. In this state, is this statement correct? Answer is no. Why is that? F is equal to ma. When you burn fuel, mass reduces, acceleration will what? Increase. So the more you burn fuel, thrust is constant, acceleration will increase. Right? The more the fuel is burned, hot gas is pushed out of the vessel. Hot gas is pushed out of the vessel. Hot gas is pushed out of the vessel. According to law of conservation of linear momentum, the rocket is pushed in the forward direction. The rocket is pushed in the forward direction. The rocket is pushed in the forward direction. For this, there is no effect from atmospheric pressure. For this, there is no effect from atmospheric pressure. Right. In reality, acceleration increases as it burns fuel, even though the upward thrust is constant. Upward thrust is constant, mass reduces, acceleration will increase. Right there. According to the equation F equal ma, if the thrust force is kept constant, when the mass reduces, the acceleration will increase. When the mass reduces, the acceleration will increase. When the mass reduces, the acceleration will increase. Sketch the Vt graph. So acceleration keeps on increasing. Time is second. V meter per second. Acceleration will keep on increasing. Right. Please name the axes correctly. Name the axes correctly, otherwise they'll cut marks. Next one. Consider a situation where the shuttle. Now, what's the mass of the shuttle? Mass of the shuttle is 2 10 to the power 6. Right. Travels at 400. The mass of the shuttle at this instant is 1 10 to the power 5. Okay, 1 10 to the power 5. It's given in the question, sir. 1 10 to the power 5. Right. Okay. Unfortunately, due to an internal explosion, the shuttle breaks into two equal parts, P and Q. Now the shuttle is breaking into two equal parts means 10 to the power 5 divided by 2 kilogram. 10 to the power 5 divided by 2 kilogram. Now when the rocket is traveling, mass has reduced. He is the new mass. Right. If the speed moves forward with the velocity 800 relative to Earth, determine the velocity of Q relative to Earth. So here this is velocity of P with respect to Earth. Let's find velocity of Q with respect to Earth. This is velocity of the shuttle with respect to Earth. Remember, when you apply law of conservation of linear momentum, all velocity should be with respect to Earth. All velocity should be with respect to Earth. You must write it. Applying law of conservation of linear momentum. Law of conservation of linear momentum. Law of conservation of linear momentum. Total initial linear momentum. I write short form, but you write in full words. Write in full words. Total initial linear momentum of the system equals total final linear momentum of the system. Initial linear momentum, how much? 10 to the power 5, travels at 400. After explosion, 10 to the power 5 divided by 2. Velocity of Q with respect to Earth. 10 to the power 5 divided by 2. Velocity of P with respect to Earth 800. What can you say about the masses here? 10 to the power 5, 10 to the power 5, 10 to the power 5, cancel out. Okay. Simplify this. Multiply by 2. 400 times 2. BQ, E. 800. 800 cancel out. View Q, E is 0 meters per second. 0 meters per second. So velocity 0 means it's falling vertically under gravity. Falling vertically under gravity. Once you need it, write it down. Falling vertically under gravity. Right. Briefly state the subsequent motions of P and Q. Q falls vertically under gravity. falls vertically under gravity. P travels as a horizontal projectile. Horizontal projectile. In horizontal projectile motion. Horizontal projectile motion. Okay, now that will go at 400 and 804 in projectile motion. Right. If the explosion lasted 0.2 seconds, what is the average loss? Let me apply F equal NB minus NU divided by 2 on Q. Mass of Q 10 to the power 5 divided by 2, final velocity 0. 10 to the power 5 divided by 2. Initially, what can you say? Initially, both these parts, this part and this part was going at 400. So Q was also going at 400. P was also going at 400. Then explosion only changes. Initially, both these parts are going together. So here, 400 forward direction divided by time 0.2 simplifies minus 10 to the power 5 divided by 2 times 4000 divided by 2. That's the force. F is equal to 1000 minus 10 to the power 8 Newton forward direction. Force on Q is 10 to the power 8 Newton opposite direction. Every action has equal opposite reaction. Force on P will be 10 to the power 8 Newtons in the forward direction. 10 to the power 8 Newtons in the forward direction. Okay. Right. Okay, now? Right. So you can clearly see today we have finished. What have we finished? Here we have finished so today 20 MCQs done. 20 MCQs done. 20 MCQs done. One structured essay. One essay done. Altogether now 4 weeks. No? How many MCQs? 200 MCQs done. 200 MCQs done. 4 structured essay. 4 essays done. 4 structured essay. 4 essays done. Okay, no? Right. So 60 MCQs every week. So 3 is the 4th week. So 4 structured essay, 4th week, 3rd day. I'm sorry, we have done more. So 1 structured essay today. So altogether how many structured essays? 3 times 3, 9. 9. This is the 10th one. Sorry, 10th one. Erase and do this. 10th one. 10 structured essays, 10 essays done. Okay. Every week we do 3 essays, 3 structured. 5th week we will be doing more. So 4th week 10 structured essay, 10 essays. So there is progress. That's more than enough progress. So make sure you keep on doing the same thing. Remember, you have now passed that basic threshold of not doing it. Now you can see now if I normally have to come after class only and do this. So even if I get 5 minutes late, you all are sending message, which means you all are interested. So keep that interest continuously for the next weeks, next actually 19 weeks. And once your exam is there, you will be in your optimum level to write the exam well. So wherever you are, you can share the link, you can give it to your friends, whether they come to class or not. Wherever they are in Sri Lanka, share it so everybody gets a chance to get their result better. And I'll be happy if everybody can do well, and that's the happiness I will get from this, isn't it? So keep working. See you tomorrow around the same time for week 4 day 2. Stay home safe.